Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 3, Estimating Centers and Interpreting the Mean as a Balance Point. Classwork example. Your previous work in mathematics involved estimating a balance point of a data distribution. Let's review what we learned about the balance point of a distribution. A 12-inch ruler has several quarters taped to positions along the ruler. The broadside of a pencil is placed underneath the ruler to determine an approximate balance point of the ruler with the quarter. So what they're saying is if we put the ruler, say this was behind, let's say it's a clear ruler and you can see through it. We put the pencil here, 6 is the center. So if I balance this ruler on this pencil at 6, it would stay balanced because there is 6 inches to the right, 6 inches to the left. The weight would be distributed equally along both sides of that pencil. But if I put a quarter on this at 1 inch, it's much heavier over here, obviously, and the ruler would tilt and fall to the left. And that is 1, 2, 3, 4, 5 inches from center. But then if I put a quarter at 11, because 1, 2, 3, 4, 5 is this way, since I subtract 5 this way and put a quarter, it's too heavy on the left. But if I put a quarter at 11, it would be balanced again because they're the same distance from the center. This ruler would balance with a quarter at 1 and 11. But then when we throw this 9 here, the quarter on the 9, it would fall to the right again. I would have to go over 1, 2, 3 to center, and then 1, 2, 3, and put a quarter at 3 for it to balance again. But since we don't have that 3 there, this would fall to the right. So it says Sam taped 3 quarters to his ruler. The quarters were taped to the positions 1 inch, 9 inch, and 11 inches. If the pencil was placed under the position 5 inches, do you think the ruler would balance? Why or why not? So now we're going to put the pencil at 5. So now this quarter to the left is 4 units. 4 units from 1. So I'd have to go 1, 2, 3, 4 units the other way. So if I move this over like this and erase one of them and get rid of that 5, I would have to have a quarter at 1, 2, 3, 4 at 9, and I do. That would balance if we only had the quarter at 9. But we still have this quarter at 11, so it'd still be too heavy to the right. And it would not balance empty at 5 because there's an inch of plastic on this side as well. So do you think the ruler would balance? And the answer is no. It would fall. I'm not going to write this, I'll just say it. It would fall to the right because there's 2 quarters to the right of 5 and only 1 to the left. And 5 is pretty close to the center of the ruler, so this 1 inch difference wouldn't help much. Number 2, if the ruler did not balance, would you move the pencil left or right of the 5 inch to balance the ruler? Explain your answer. Okay, well, I would move it to the right because we want it closer to the heavier objects, and maybe put it, say, at 8 or even closer over here somewhere. So these 2 quarters would be heavier on this side. All this plastic plus this quarter would have to equal the weight of the plastic on this side plus these 2 quarters, so I would move it to the right. Okay? Again, I'm not going to write this, I'm just going to explain. Number 3, estimate a balance point for the ruler. Complete the following based on the positions you selected. Okay, so if I go back to that ruler, and let's erase all this, and I want to estimate a balance point with no quarters on it, okay, I've already done this, I would say it would be at 6 inches. Okay, so now going back here, I'm just going to write that. My balance point is at 6 inches. Distance from quarter to your estimate of the balance point. Well, if a quarter is positioned at point 1 and it's 6 inches is my balance point, 6 minus 1 is a distance of 5. 9 minus 6 is a distance of 3. 11 minus 6 is a distance of 5. Okay, number 4 says, what is the sum of the distances to the right of your estimate of the balance point? Okay, so to the right means greater than 6, so that's these two. So the sum of my distances is 3 plus 5, which equals 8. What is the sum of the distances to the left of your estimate? Well, to the left is any value less than 6, which is 1, and the sum of the distance is just that one value of 5. Do you need to adjust the position of your balance point? And the answer is, using a balance point of 6, an adjustment is needed, so yes. Yours may be different if you chose a different balance point. The balance point is found by increasing the distances to the left and decreasing the distances to the right. Okay, so we want to add to the left and subtract from the right. So I'm just going to say that. By adding distances to the left and subtracting from the right. Okay, so there, change it to text. Hopefully that's more legible. Number 7, calculate the mean and the median of the position of the quarters. Okay, so we want to calculate the mean and the median. So our position of our quarters is 1, 9, and 11. So to find the mean, we would take 1 plus 9 plus 11 and divide it by the number, which is 3. 1 plus 9 is 10, plus 11 is 21, divided by 3 equals 7. So the mean is 7, and the median equals the middle number, and since there's only 3, the median is the middle number 9. Does the mean or median provide a better estimate of the balance point for the position of the 3/4? Tape to the ruler. Explain why you made this selection. So which is a better measure of center, the mean or the median? Okay, so let's take a look at our data. If I chose 7, so first of all, if I chose 7 as my mean, as my center, and then I go up here and look at my data, this is only 2 units away. Not 2, I'm looking at the distance already. 1 to 7 is a distance of 6. 9 to 7 is a distance of 2. 7 to 11 is a distance of 4. These two are to the right, this one's to the left. 4 plus 2 is 6. So that they would be equal. So I have an equal weight with the mean, so that in that case I would definitely choose the 7. Now I'm going to continue explaining this with the median, see what happened with the median. The median was 9. The median was 9. So 9 is right at 9, but this distance to the left, 1 is 8 units from 9, and 11 is 2 units from 9, so this side would be way heavier and drop down. So that is why we would choose the mean of 7 as our center. Okay, exercises 8 through 20. It says 22 students from the junior class and 26 students from the senior class. Okay, so this has 22 and this has 26, so we don't have to count the dots. Okay. At River City High School participated in a walkathon to raise money for the school's band. Dot plots indicating the distances in miles students from each class walked are as follows. So anybody who participated walked some distance. So one person walked a mile, two walked 2 miles, three walked 3 miles, four walked 4 miles, and 7 walked 9 miles. That's the mode, if you remember that term, most frequently occurring. Number 8 says to estimate the mean number of miles walked by a junior. So here's junior, and we want to estimate the mean. Mark it with an X. Well, if I look at this, if 9 was the average, I have 5 points to the right, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the left. So I would estimate it at being 8. So I would say the mean would be 8. That's my estimate. How did I estimate that? Well, I'm looking at the skewness of this data. You would think that the mean would be 9, but I think that these values would pull it a little down, so I'm going to choose 8. 9 says, what's the median of the junior data? Well, 22 values, we want the 11 and 12 values average. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 would be these two values. So the median would be 8 plus 9 divided by 2, which is 17 divided by 2, which is 8.5. Number 10 says, is the mean number of miles walked by a junior less than, approximately equal to, or greater than the median number of miles? If they are different, explain why. If they're approximately the same, explain why. Well, the mean is a half of a mile less than the median. It is a little bit less. They are different, so explain why. Well, if the median is 8.5, which is right here, and the mean is a little bit less, it's because of these not outliers, but skewed data. Okay, so the reason is the people who walked 1 through 4 miles pulls the average down. Okay, so there's the explanation. The mean is less than the median. The smaller cluster of data values to the left pulls the mean in that direction. They're talking about these here. Right here. The median is not affected by the values of those points. Okay, median is not affected by outliers. 11 says, how would you describe the typical number of miles walked by a junior in the walkathon? Okay, what I would say was the mean probably how would you describe the typical number of miles walked by a junior in this walkathon? I would probably say something like the mean appears to underestimate the distance walked by a junior. What else? Let's think. 8 students walked less than the mean. So if the mean is 8, 1, 2, 3, 4, 5, 6, 7, 8 students walk less than the mean, but a lot more walk more than the mean. Therefore, the mean is probably an underestimate. Number 12 says to estimate the mean number of miles walked by a senior and mark an X. How did you get to that estimate? So estimate the mean, I would say the mean equals now we're looking at the seniors. Let me change colors. The mean is an average. You might think that it's 6 because that's the center, but there are 1, 2, 3, 4, 5, 6 to the left, 1, 2, 3, 4, 5, 6 to the right, stops there, and then there's all these. So I would probably move my estimate to 7. Okay, so it said to mark it with an X. So I would probably say that 7 was the mean. But then 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the left. But there are larger 11 and 12 outliers here. 11 is a lot more than 3, so I'm going to stick with my 7. I would say that the mean equals 7. And me explaining that verbally was my estimate, how I estimated it. Number 13 says, what is the median of the senior data distribution? Remember, there were 26, so I've got to find the 13th and 14th and average them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 are both 7. They're equal. So the median equals 7 plus 7 divided by 2, which is 14 divided by 2, which is obviously 7. So the median is 7 and the mean is 7 in my estimate. So 14 says estimate the mean and the median of the miles walked by seniors. Well, definitely I would say that it would be 7 because they're equal. Is your estimate of the mean number of miles less than, approximately equal to, or greater than the median number of miles walked? And they are approximately equal. If they are different, explain why. If they are approximately the same, explain why. Well, they're approximately the same, so the reason is the data is evenly distributed. That's got a nice, even, smooth curve, like a bell-shaped curve. There's no skew in the data. Okay? How would you describe the typical number of miles walked? Since the distribution is symmetric, the mean and median are approximately equal. A good estimate for both is around 7 miles. Let me put that there. Number 16, a junior from River City High School indicated that the number of miles walked by a typical junior was better than the number of miles walked by a typical senior. Do you agree? Okay, so they're saying the junior's typical walk was better. So the seniors, it was a more even data distribution. Juniors was skewed left, clustering up to the right. Okay, so how do we approach that? So I would agree with him. The median is a better indicator of a typical value for the junior class. The median of the junior class is more than the median of the senior class. Okay, so if we use the median from the juniors, it was 8.5. The median from the seniors was 7. 8.5 is more than 7, so the juniors win. All right, number 17. Finally, the 25 sophomores who participated in the walkathon reported their results. A dot plot shown below. So many walked 1 and 2 miles, nobody in between, and then there was a whole bunch that walked 9 and 10 miles. So maybe they walked in groups, 2 groups. One group called it quits after 2, one group called it quits after 9 and 10. Okay, so now answer the questions. What is different about the sophomore data distribution compared to the data distribution of juniors and seniors? This is a, I don't know what you would call that. So if I were to draw a distribution, okay, if I were to draw a distribution, it would come down like this to 0 and then work its way back up, so it kind of looks like a U shape. Half the sophomores walked over here, the other half walked over here. The juniors had a skewed distribution, seniors had a symmetric distribution, and this is something totally different that I'm not going to mention at this time. So there's 17. What's different? It's not skewed or symmetric, it's 2 different groups. Okay, 18. Estimate the balance point of sophomore data distribution. Okay, so if I were to estimate this, let me get this U shape out of the way. Okay, an estimate would probably be the mean and I would say it's probably somewhere in this area here. So how about the mean equaling 5? What is the median number of miles walked by a sophomore? Well, how many sophomores are there? 25. It's an odd number, so we have to find the middle, which is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so the median equals 2. How would you describe the sophomore data distribution? We've already done that. It's a U-shaped distribution. You either had small or large data. The mean and median are not good indicators of a typical distance. Neither one is a good indicator. Nobody walked 5 miles. Nobody, and the median 2 miles, that's way underestimating the 9 and 10 mile walkers. Okay, so since it is not evenly distributed or skewed, neither the median or the mean are good measures of center. Okay, so that is the end of lesson 3. Review your lesson summary and go do your problem set.